Hello everyone, we're starting off Spiral 3 with a discussion on trigonometry. And we've seen trigonometry before. In Spiral 1, we looked at right triangles. And in right triangles, we had this idea of the opposite, adjacent, and hypotenuse as our sides. And to find those sides and angles in right triangles, we used sine, cosine, and tangent. In Spiral 2, we looked at other triangles that don't have a right angle, and to solve them, we looked at what was called the sine law. But the sine law only works when you know a complete side and angle pair. So in Spiral 3, we're going to look at what do you do when you don't know that much information? What do you do when you don't have this complete side and angle pair? Well, it's called the cosine law, and that's what we're going to look at in this lesson. So if you're able to print off the handouts, then you can follow along with that. If you're not able to print them off, you can just write your own notes on a piece of paper and follow along with the video. So I mentioned we're talking about the cosine law, and just as a reminder, we need to remember how to label triangles properly. So here I have a generic triangle ABC, and we notice that all the angles are labeled with capital letters. The sides will have the same letters, just lowercase. So if this is angle A, the opposite side is going to be side A. This is angle B, the opposite side is going to be side B. If this is angle C, the opposite side will be side C. So now that we've got the labeling covered, I'm going to show you two different ways of writing the cosine law. The first way is for solving an unknown side, and the second way is for solving an unknown angle. Now there's some things I want you to notice. I want you to notice this first, that labels are arbitrary. So I have the letters A, B, and C corresponding to the sides in my generic triangle ABC. But for the purposes of using this formula, C is just going to be the side that we're trying to figure out. A and B are just going to be the other two sides. So the labels in your actual question might be different. You might not be finding side C, but the side that you want will go in this spot. The other two sides will go in these spots. Now this angle C, remember the position, C and C are opposites. So whatever side you're trying to find, it's on the opposite side to this angle. So you have to put that angle in this spot. Likewise over here, when you're trying to find an angle, you might not be trying to find angle C. The labels might be different, but this is just whatever angle you're trying to figure out. This side C, this is the opposite side to the angle you're trying to figure out. A and B are just the other two sides. The labels are arbitrary. What's important is the position of the numbers that you are putting in the formulas. This is the side you're trying to find. This is the angle you're trying to find. And when you're trying to find this angle, it's very important that you're putting the opposite side in the right spot. Otherwise, you're not going to get the right answer. And hopefully this will make a little more sense once we do some examples. So let's look at the first one. Find the value of C correct to one decimal place. So C is here. That's this side. We're trying to find a side length. So we're going to start with the cosine law set up to find an unknown side. Now it just so happens that the side I'm trying to find is C, and this is already set up with a C right there. And just remember, A and B are just the other two sides in the triangle. It doesn't really matter which order you put them in. But once you fill in your numbers, then you just plug this into your calculator. Remember, This is just multiplication, so it's 2 times 26 times 12 times the cosine of 60. If you have a nice calculator, you can just type all this in one step, exactly as it looks. If your calculator requires you to do it in more than one step, I would recommend to do each term separately. So do 26 squared first, do 12 squared separately, do 2 times 26 times 12 times cosine 60 separately, and then you do this answer plus this answer minus this answer. Any way you do it, you should get this. And if you don't get this, this is something you should be asking me for help on, because there's a number of various... So you'll need to make sure you reach out if you didn't get 508 as an answer at this point. Okay, so let's say you got this answer. Now, a lot of people are going to want to stop right here and say, C is 508 centimeters. But that's totally wrong, because this isn't C. This isn't what C is. This is what C squared is. C squared is equal to 508. So we need to do a little more work to find C. So to find C, we need to do the opposite of squaring, which is square root. So C is the square root of 508. And that ends up being 22.5 when we round it to one decimal place. So just to recap quickly, if you want a side, use the side formula for cosine law. Plug in your other two numbers in the A and B spots. The angle is the angle that's across from your unknown side. In this case, it was 60 degrees. Put it in your calculator. Don't forget the square root, and then you end up with your final answer. Here's the next example. Find the value of angle A, correct to the nearest degree. So this time, instead of finding an unknown side length, we're trying to find an unknown angle. So we're going to start with the cosine law written in this form so that we can find our unknown angle. Now this time, the labels aren't going to match. So remember what I said, the labels might not match. Like, we're not trying to find angle C in this question. We're trying to find angle A. But it's the position that matters. So this is the angle we're trying to find. So this is A. This is the opposite side, which will be 7 centimeters. A and B are just the other two sides, the 10 and the 8. So we can fill in our cosine law like this. So a lot of people are going to make the mistake of not putting the 7 in the right spot. Remember, 7 is the side that's opposite the angle we want. So that is the one that has to go in this spot, the one that's being subtracted. If you don't do that, let's say you put the 8 here instead of the 7, you're going to get the wrong answer. So this is something you really have to watch out for, is you need to put the opposite side to your angle in the right spot. Okay, so you've reached this point. You've plugged in your numbers. This is a fraction. Sometimes people have trouble when they're typing this fraction into their calculator. They try to just type in 10 squared plus 8 squared minus 7 squared divided by 2 times 10 times 8. If you do that and you don't use brackets around the top, you're going to run into some trouble. So I would recommend, if you're putting it all in one step in your calculator, to put brackets around the top part. So put 10 squared plus 8 squared minus 7 squared, the whole thing in brackets. Then divide by this in brackets. So make sure you use your brackets, or you can just do this in more than one step. So you can just do the top, 10 squared plus 8 squared minus 7 squared, and get your answer. Then do 2 times 10 times 8 separately, get your answer. So now we have 115 divided by 160. So we can do that, and we get 0.71875. A lot of people are going to run into a mistake here. They're going to stop and say, well, angle A is 0.7 degrees, or they'll round it up to 1 degree. Or they'll do something weird and multiply this by 100 because they think it's some sort of a percent, and they'll say it's 72 degrees. I've seen a lot of weird stuff happen at this point. But we're not saying that this is the angle. We're saying the cosine of the angle is this number. So again, to find the actual angle A, we have to do the opposite of cosine. And we've seen this before in spiral 1 and spiral 2. Whenever we're trying to find the angle, we have to do the inverse. So here we'll do the inverse cosine. It looks like the cosine minus 1. When you do that in your calculator, you'll have to press your shift button or second function to access it. Any way you do it, you should get about 44 degrees, and that is angle A. And here's my last example for this lesson. The pendulum of a grandfather clock is 100 centimeters long. When the pendulum swings from one side to the other side, the horizontal distance it travels is 9.6 centimeters. Determine the angle through which the pendulum swings. So I have a visual here. That's a grandfather clock in case you're not sure what I'm talking about. The pendulum is this part here that hangs down, and it swings back and forth. So as it swings back and forth, it swings through a certain angle. And that's the angle we're trying to find. Now I'm told the pendulum is 100 centimeters long. So if I look at my little diagram here, that's the pendulum, that's 100 centimeters. That's also the pendulum on the other side, that's 100 centimeters. The horizontal distance it travels is 9.6 centimeters. Well, here's the horizontal distance it travels from side to side right here. So here we have a triangle, and we know all three sides. We're trying to find this angle. So I can use my cosine law to solve this. So I just use my cosine law written in this way to solve for my unknown angle. So my unknown angle is x. The side that's opposite the x is the 9.6 centimeters. So that is the side that I put in this position. The other two sides just go in the other two sides spots. So now I just do the math, do the top, do the bottom, divide, and then I have to remember to do my inverse cosine. So I get an angle of 5.5 degrees. Now, if you have the handouts printed, I want you to notice something. At the bottom of the handout, I've got these homework questions. Just ignore those for now. I have a different practice sheet for you.